Okay, so let's wait. I've just started this device. Okay, so before going through, I just want to explain today something about the destination NAT. Okay, so how we can achieve it and what kind of scenarios we can get. So whatever I've explained now till now, static NAT, NAT, dynamic path. So dynamic path is what I've already explained. It that is dynamic path. Many people used to say many to one. Okay, like many local IP change to one IP. Okay, for dynamic path NAT. People used to say also many to many because many to many. Like if we have a local IP also in multiple form, multiple IPs, and also we have a multiple public IP, multiple public NATed IP. Okay, and static IP, static NAT, we know it is one to one NAT. Okay, one to one. Okay, so that's how people even used to say like this. Okay, so dynamic PAT, dynamic NAT, static NAT, those all are I think all are complete. We have also done the lab. So now with the help of static NAT only, we will achieve destination NAT. So as I explained that, what would happen? This is my firewall. Nowadays is actually happening because I have seen and I have walked such kind of scenarios. Like this is my PC from the outside internet. Okay, and this is my inside, and there is one of my okay. You see, this is my outside network. Fine. And suppose if we have a DMG, okay, DMG network, and guys, suppose we have a two subnet here, two PC here. Okay, subnet is same, two PC. Okay, and IP of like this PC IP is 10.0.0.1. This PC IP is 1.1.1.1, and this PC1 and this is PC2, guys. This IP is this subnet is actually like suppose this one has IP of 172.16.1.1. This one has IP of 172.16.1.2. There is nothing called one to many. Okay, guys. So see that. Just try to understand. Okay, only focus on DMG. So like if we have some such kind of scenarios where like my public IP, okay, my public sites want to access both of the server. If we have a two server, okay, two web server, those are public facing server. If someone would say public facing or internet facing server, it means from the internet people are coming and accessing those server. Okay, so like suppose we have a two PC, but the condition is I want to use only one public IP. This is condition, one public IP. I have only one public IP, and with this one public IP, like I have a public IP is 2.2.2.2. Okay, guys, with this public IP, I want that any traffic from the outside, any traffic from the internet can come to access both of the server. Any traffic would come only these IP. Okay, any traffic would come and try to access these of the PC. It means in one public IP, those both PC should be able to work. The source is from the internet. Okay, so here what we are looking for, we are working on the destination NATing. Okay, it means from the public, the traffic should come from the public and access both of the PC. Okay, this is the condition, this is the requirement. Okay, guys, from the public it should come and get the access both of the server, and we have only one public IP which has IP of 2.2.2. Okay, so how we can do that? So this condition actually, see, destination NAT, we know that. What is destination NAT? Like source IP is NATing, the same way as destination NAT is NATing. So we will see here in this example, we will learn two things. Okay, I will explain later on. So first, how we can do that? If we talk about the original packet, guys, original packet. Okay, always whenever if you're doing NATing, always distinguish it in two packet: original packet and translated packet. Original packet, guys, source zone. I will talking about the zones later on, guys. Okay, it's very important. But source IP, I could see it's 1.1.1.1. That is fine, guys. This is my source. Okay, and what is my destination IP? Definitely destination IP is 2.2.2.2. Okay, that is fine. Like this PC, this PC3 try to access PC2 first. Okay, PC2 first in my first condition. Okay, he's accessing 2.2.2.2. That is clear. Okay, but also he want to access port number 443. That's fine. This is my original packet. What would be my destination translated packet? The translated packet, guys, source IP is my same 1.1.1.1. Destination IP. Okay, my firewall will how my firewall will convert it. I will explain that. See that, guys. Don't be confused. If there is only one PC, if there is a if just for a 1 minute, suppose there is only one PC, only one PC. Okay, only one PC, and this IP is dedicated NATed to these IPs. So which we have already learned static NAT, right? The static NAT both can communicate each other, right? That is clear. But with this one public IP, I want to on one public IP, I want to assign, I want to access from the internet, I want to access two PC, okay, two server locally. Okay, so what would happen? The translated packet source is 1.1.1. That is fine. Destination, I don't know yet. Because where my firewall will forward the traffic, I don't know it. So how my firewall will forward the traffic? It is forwarding in the based of port. That's called port forwarding. Okay. I will explain what is port forwarding. It's very easy. You guys will understand. That's it. Just like a dynamic path, the same here, like it's using a destination port 443. What it does, we will do some such kind of configuration that if any PC will try to access PC2 on the port 443, like this one, whenever if this will initiate a traffic on port 443, it will come to this it will come to this PC. Whenever if this will initiate a connection on port number 80, it will come to this PC. So that's how the connection would be. So whenever the port 443 would come, it will forward to port 8080. Okay, we have, and it will give the IP 172.16.1.2. If he will initiate a traffic on port number 80, suppose, so what it will do, my firewall will do that. Okay, he's initiating a port number 80. So then he knows that, okay, for port number 80, if initiating traffic on destination IP 2.2.2 on accessing port number 80, for port number 80, I need to send the traffic to PC1. Okay, so that's how with the help of port translation, we can achieve accessing a several PCs, not one even, not two even three, even four. One public IP with the help of port translation, we can able to make a communication from outside internet to the inside services. Okay, let me explain again. So what is happening here? The thing is my firewall, and this is my PC. Okay, PC1 whose IP is 172.16.1.1.2, and this one has a IP is PC1, PC2, 172.16.1.1. So what would happen if someone will try to access on port 80? So firewall will forward the traffic to this PC, and someone will initiate a traffic on port 443. So traffic will forward to this PC. That's how actually the concept. Okay. Okay. So there we are using even the destination NAT, and also we are using a port translation. Okay. So this PC is 1.1.1. Okay. And this is NATed to 2.2.2.2. So whenever this PC with the IP 1.1.1 will initiate a traffic to 2.2.2, if the port number is 443, my firewall will forward the traffic to this PC. That's it. If he's accessing on, if this PC will accessing on port number 80, my firewall will forward to the PC1. So that is called port-based translation or port forwarding. So with the help of one public IP, we are doing the destination NAT, and even with the help of port services, we can forward the traffic accordingly to the different server. And nowadays, this is actually in the very much in the fashion. Okay, everywhere we can see this kind of connectivity nowadays. Okay, if suppose my source IP is 1.1.1, okay, and destination IP is 2.2.2, okay, okay, that is fine, and he want to initiate a connection with the port 443. So I have make a such kind of configuration of the firewall. Whenever this PC 1.1.1 initiate a connection for 2.2 on the port 443, it will translate to this PC. So what would be my translated packet? Translated packet would be source would be 1.1.1.1, and destination would be 172.16.1.2, and the port would be 443. Keep it like this. Okay. And if he initiate a packet for 80, that time what would happen? The same connection, but it is for the 80. What would happen? My source IP is 1.1.1.1, and my destination IP is, it will change, because for the port number 80 services, it will forward, firewall will forward the traffic to this PC 172.16.1.1, and port number is 80. So this is, I'm talking about the destination port, not the source port here. Okay. For the source port, only dynamic path was happening, but for the destination, we are NATing here. The destination NAT is going to do, and also we are achieving by the port translation also, port forwarding also. So both things we can do. So simply, I would say that for the destination NAT, okay, for the destination NAT, just learn the basic of destination NAT, nothing, just like a static NAT only. Okay. Just for the static NAT only, if you have a firewall, same example, this is my internet 1.1.1.1 IP. Okay. And it is coming to only, I have a one PC which have a IP of 172.16.1.1. Okay, and it is, I have assigned one public IP 2.2.2.2. So if whenever this would be become a source, what will be my original packet? Source IP would be same 1.1.1.1. Destination IP would be 2.2.2.2. That's fine. Port number would be anything. Okay, right now I have only one PC here. Just example. Port number would be anything. Anything is any I'm putting. Okay, anything. Okay. And now here the translated packet would be what? Guys, just see that translated packet is source is 1.1.1 and destination is, because this PC is NATed to 172.16.1.1 and port number whatever the port is accessing. So this is the simple static net, right? This is a simple static net. So that's why I have added, with the help of one IP, we can achieve right now this example. We can achieve with the help IP. This is a simple static net. So destination net, with the help of a static net, we can achieve it. Okay. So like the example, if we have a multiple PC in the server, if I have multiple PC, and in the condition is if I want to use one IP only, so how we can achieve it? Okay. So if we have only one public IP and I want from the internet someone would come and try to access my internal web server, how we can achieve it? So with the help of services, we can define that. If the same source, if coming to the destination 2.2.2 on the port 443, my firewall will forward the traffic to this PC, because this PC is running on 443 services. Okay. So, and for this PC, if he will initiate a traffic on 80, it will forward the traffic to this PC. So that's the basic concepts, we can use it. Okay. So now go and let's do the lab for that.